Most machine learning projects fail. This is going to turn out to be a great opportunity. Welcome to the Dr. Data Show. This is Eric Siegel, and today I'm going to talk about brand new industry survey results showing that the vast majority of models generated with machine learning with the intent to be deployed actually fail to be deployed. We'll talk about why it's an opportunity. I'll step through the specific survey results, talk about the leadership practice that's generally missing from machine learning projects, and we'll take a few questions from our listeners. So KD Nuggets, which is a major industry portal for machine learning and data science, conducts these industry polls, and so I knocked on their door. I said, hey, have you asked this question? How many of your models are actually getting deployed? And it turned out they were interested. And longtime colleague Gregory Piateski, who actually founded KD Nuggets, and the new leader of KD Nuggets, Matthew Mayo, they were both interested. They helped me formulate the question and wordsmith it. And the first of three questions was, what percentage of machine learning models created by you or your colleagues with the intention of being deployed have actually been deployed? And more than half said only 0 to 20%. 0 to 20%. We had the answers in 5 bins, so people could say, well, between 0 to 20%, 21 to 40%, 41 to 60. 5 bins. And 58% said 0 to 20%. In the next bin, 21 to 40%, we had 21%, and then the other 3 bins only had 7% each. So the vast majority of data scientists say that only between 0 and 20% of their models that were generated to be deployed actually get there. So in other words, that is to say, most data scientists say 80% or more of their projects essentially stall before deploying. They fail in that respect, which is an astonishing low success rate. So we've seen this kind of thing before, and there's been an increasing industry buzz about, hey, there's a lot of excitement about the technology. The technology is quite adept. It's amazing, has so much potential and promise. But is it really delivering value? Is it getting operationalized? Is it getting deployed? So, for example, but there's been relatively little in the way of actually concrete industry research, trying to get a sense of the degree to which this is a serious issue. So Rexer Analytics several years ago showed 13% of data scientists saying, only 13% saying that their models are always deployed. And more recently, their 2020 survey, Carl Rexer himself told me, 11%. Beyond that, most of the surveys are less from the data science side and more from the managers, and are sort of more general questions like, are you getting value? But they're all pretty much consistent with the brand new results that we're getting here. So we've definitely kind of reconfirmed this, as well as the general anecdotal, there's one Gartner analyst who estimated that close to 85% of big data projects fail. So there's been this general lore, a lot of anecdotal information, a lot of question. It doesn't seem to be quashing the hype about AI, machine learning in general, which I feel is a good thing. I'm very much a proponent of machine learning. But it also does not seem to be cajoling the course correction that we need. So here's the root cause of why models fail to get deployed. What's missing is not a technological problem. It's not something in the technology or the quantitative methods. It's a process management issue. It's a lack of leadership. You need to have the right, astute, specialized machine learning leadership practice in place where you define ahead of time exactly how this thing's going to get deployed. And only by way of doing that and having a highly collaborative, intensely collaborative work between the data scientists, the hands-on quantitative practitioners, and the business side, the business professionals, the business leaders, the decision makers, in many cases executives themselves, line of business managers where the actual thing's going to be deployed and actually make a difference in business. Only by doing that do we stand a chance of actually getting successfully to deployment? So it's very much two different things. One thing to actually do the number crunching and generating a model that's sound. It's another thing to generate one with all of the business constraints in mind, those constraints that only come up through that collaborative process. And then kind of getting it greenlit, getting it socialized. So really, here's the problem. We see machine learning in terms of its business execution and its use by an enterprise. We see it as a technology, but it can't be seen that way. It must be seen as an organizational endeavor, with one component being the technology. And that's an adjustment, that's a course correction that's going to be painful, and it's coming. It is in the pipeline as we get disillusioned with a lack of business. I mean, at some point, the stuff is going to hit the fan, right? As we get increasingly disillusioned, more and more disappointment in terms of actual value achieved. What's the matter? Why didn't progress sort of push through this? Well, the problem is it's not technological progress. It's the progress of organizational understanding and organizational process that needs to, holistically deal with how this stuff is put into place. So let me put it another way. So many of the techies just have the impulse to get hands-on, including newcomers, right? The vast majority of courses in machine learning and books they basically presume that the data is already prepared. And literally the first step is, open the software and load that data. That data is sort of presumed to already exist. Now, data preparation is a huge, hairy challenge, and it's generally considered to be a bigger technical endeavor than the actual modeling itself. But that's not the only issue at all that I'm alluding to here. The definition of what that data should be, the training data in the first place, very much hinges on the business process, the business understanding, and the collaborative, intensely collaborative, iterative, continued management practice that brings together those business leaders. And only by doing that do you get two things. You get to make sure you're predicting the right thing, that is, you're modeling the right thing, that you've set up the data for the business problem that's actually the most practical and pragmatically going to be useful, and that's been greenlit, that there's been understanding, it's been socialized, there's been buy-in, and that buy-in is sustained all the way to the point where, think of it this way. Some data wonk walks into office, oh, I made that model, look, you're going to save this much money, come on, all you got to do is deploy it. And then the business manager, the business leader, the line of business manager, whoever it is that's sort of running operations in marketing or in fraud detection or whatever it is, you're telling them they're going to need to completely change business as usual. And they're not going to just suddenly be completely comfortable with doing that. So it's a change management issue. It's a huge change management issue. Now, if you're on the data science side, if you're a technical practitioner, you could very easily be thinking, oh, geez, this is ridiculous. Some manager or somebody should be dealing with that socialization and change management, because ultimately this stuff is self-evident. It's a no-brainer. The value proposition writes itself. Why need I worry or spend time with or hold the hands of executives who don't really get it? So, for example, churn modeling, right? One of the most popular ways to apply predictive modeling or machine learning for marketing, for targeting marketing. You're predicting which customer is going to leave, who's at the highest risk of defection, in order to more effectively and efficiently target any kind of retention resources or discounts or whatever might cost you, salesperson time, whatever it is, to have a more focused and effective use of those resources or time to try to keep the customers around who are most at risk of leaving. That's a great value proposition. It's such a no-brainer in a way once you see it put on the table. It's not the rocket science part. But no, you can't just sort of presume that the organization as a whole will adopt it, will actually go to deployment, will actually change the existing operations or introduce a new operation based on the number crunching, the model that you've developed on the data. So here's the huge mental shift. And I'm only going to say this once. No, the fact is I'm not going to only say it once. I'm going to say it like over the course of this podcast episodes. I'm going to say it 500,000 times in different ways. But I'm saying I'm only going to say it once to make sure you really listen. The concept of the machine learning project is about that deployment. It's not about the modeling. The main event is not the creation of the model. It's the actual getting it deployed, that is to say integrated so that it actually affects operations. Your part, if you're the data scientist, of actually turning out that model, making sure the data is sound and making sure the model performance is sound and explaining what it is and how it works and how well it works, the performance measures to others at your organization, all that, you know what? It's actually just one component of a much bigger umbrella project, which is how do we get an end-to-end practice that's going to include that technical process and then also include the integration and the green lighting and the understanding and the management of it moving forward. This is a revamping of the main large-scale operations. This isn't, you're a rocket scientist, so to speak, right? But this isn't about you. And this isn't about the science. This is about a company that needs to make a major change in paradigm and how they're conceiving of the way major processes are conducted. So the disease, the diagnosis of which this is all a symptom, is that we're completely misconceiving, right? We're so excited about the technology. And believe me, that's where I come from. I'm from the technical side, and that was my original infatuation, was with how cool it is, machine induction, to actually learn from data, to generate, to find things that generalize from data. That's amazing. And I do feel it's the most exciting and fascinating of any kind of science. But its potency only comes out of a human process, that is, an organization's process, to adopt that technology in the right way. Adopt it in terms of like greenlighting it, and adopt it as far as actually integrating it, actually deploying or operationalizing it, or whatever word you want to use. So that's where the rubber's not hitting the road. So the best analogy for this is, let's say you're literally a rocket scientist. You've got to recognize that the main event is not building the rocket. The main event is launching it. So the current situation is really not sustainable. This sort of infatuation with the technology, so many people becoming quote-unquote data scientists, or even within the realm of data science, adopting machine learning in particular because it's cutting edge, because it's cool and exciting and amazing. And I'm not disagreeing with any of that. But as far as it actually achieving value, there has to be a major recalibration. Now, in recent times, I'd say that this issue is actually getting to be worse. But first, because of deep learning. But first, let me just go back to something I promised at the beginning here. The opportunity is to get ahead of the curve of that recalibration, because it's coming, right? And be the hero by way of ensuring this industry company-wide practice is in place, so that you can actually be leading it to deployment and to value. So before we take a couple questions from our very intelligent listeners, I'll just say that I see deep learning as, clearly one of the most exciting things to happen in machine learning ever, but also magnifying this pragmatic issue, because ultimately deep learning is tends to be more research and development type projects. It's about something, you want to introduce something new, some kind of new operation, such as, let's say you're doing a model that essentially does image processing to suggest a diagnosis to a physician, or that informs self-driving process of an automobile. These are new operations, so it's just like our in research and development in general, you're that much further removed. The distance between the modeling and getting it actually deployed. There's that many more steps, even more than usual, right? Whereas with standard business applications of machine learning that don't necessarily use such advanced modeling methods, maybe they use log linear regression or something, such as the churn modeling example, you're not necessarily introducing a new operation. What you're doing is enhancing and improving the performance of an existing operation, such as marketing, in order to retain existing customers. Also, with deep learning, the complexity of the model is that much more complex, and yet the potential and the excitement's only increase. So it's just that much more hype and that much more drive and focus on the core technology itself rather than how it's going to get deployed. Taking that a step further, all the hype about AI, and so people love to use the word AI instead of machine learning, and arose by any other name. The problem is that in most cases, or in general, it's somehow insinuating a kind of hype where there's the pursuit of quote unquote intelligence, which is such an elusive term, it can't escape being so subjective. And you're pursuing that quality rather than an actual solution to a business problem. So you're getting that much further away from having a focus on deployment from the get-go. So I mean, I'm as you'll learn through the episodes of this podcast, I'm very much not in favor of most of the hype around AI, and feel that legitimizing AI as a field incurs a great cost. I have a short series of YouTube videos covering that you could find at theaiparadox.com. In any case, let's before we wrap up, let's see. I believe I have a few questions from our listeners. Here's the first one.
Isn't this already addressed by MLops?
Oh, that was great articulation. Isn't this already addressed by MLOps? So yeah, as you might have guessed, especially with a brand new podcast, the majority of my listeners are actually just AIs. And I'll be making some dumb AI jokes since I'm such a skeptic of the concept. By the way, I taught the graduate level AI course at Columbia University and related graduate level courses at Columbia University. But I eschew the terminology. Not the technology, but some of the concepts and the way it's hyped. So isn't this what's already addressed by MLOps? It's getting a lot of attention these days. It has to do with operationalizing machine learning, and the answer is no, because what MLOps is, as important as it is to help facilitate the operationalization, the deployment, the integration of models. It's a practice, a discipline, and a set of technologies for the management of that technical part of the practice. It's still on the technical side, and we need the technical side, but I'm just saying what the limitations are with regard to the overall issue I'm addressing today. What you're doing with MLOps is you're managing models, their deployment, and their updates and all of that kind of stuff on the technical side. But what I'm alluding to today is the need for a leadership practice that's very much not a technical practice and is not about managing just a technical practice, but managing a much larger scoped practice across the organization so that you can move that organization towards actual deployment. All right, I've got another question here.
Are you saying that machine learning isn't generating value?
Dude, you sound a little defensive there. But no, I am not saying machine learning isn't generating value. I'm saying that there are many, many projects out there, and most of them are not generating value. They don't get deployed. They don't get to that point and achieve deployment. But that doesn't mean there aren't many that actually do, even if they're the minority. And it also really depends on context, right? So if you're at a large financial services organization and you've been deploying credit scoring models, for decades, and now you're creating a new model that's an update or even maybe a bit of a shift from an existing type model or a way that it's used. It could be an incremental shift or just a no shift at all, and you're just updating the model. Obviously, you stand a really high chance of getting deployed in that context. So to take things to an extreme, there's plenty of conditions in which, and there's plenty of industry leaders and machine learning leaders and organizations that are at the forefront that actually get things deployed. There's no question about that. I mean, all the Googles and the Facebooks, Google search itself is very much hinges on machine learning models. I'm not saying machine learning is failing universally. I'm saying that the vast majority of projects are actually failing, and it may mostly be either innovative and new projects, and there's a certain amount of faltering to be expected. But I also don't think we should write it off as that. I think that there's an endemic, if you will, issue of sort of focusing on the core technology without nearly the proportional need to also focus on the business value and the business practice and its ultimate deployment. So let's we've got two more questions here.
Okay, then who should lead ML projects?
Who should lead ML projects? So, I'm actually just a data scientist. What do I know about business operations? My answer to that question is whoever has the skills and desire to do it. It's not necessarily going to be somebody who's very technical on the data science side, but it certainly could be. There's obviously a trend, right? That the more technical and more of a quant head you are, the more on the data number crunching side that you are, the sort of more excited you'll be about conducting that stuff, and the less you'll be about the human process of management and organization-wide practice and all that. That's a trend, but by no means a rule. There's plenty of very technical people who somehow have both sides or are glad to migrate. I would say that my own career has very much taken that trajectory where, I like to say that machine learning is the most cool and exciting technology. It's cool for the reason that I thought it was cool starting in basically 1992 or 91 when I got involved, just technologically. But it's exciting because of the potential business value of it. So for me, in my personality, I get a certain kind of thrill starting from the technological fascination to, hey, wouldn't it be cool if we could actually get this into the field where the rubber hits the road and it's actually making a difference? That's also really exciting to me. And what does that take? Well, it's going to take a lot more than we might have initially assumed. Okay, let's go now to the last question.
Where can I learn more about the ML leadership practice?
Okay, well, there's plenty of reading. I've written a bunch of articles. I have an online course. Many of my colleagues have. So I'll just, first of all, point you to the Katie Nuggets article that officially summarizes and provides further detail than what I'm providing here about that brand new industry survey about model deployment. And at Katie Nuggets, my article that's like unveiling these survey results is called "Models Are Rarely Deployed: An Industry-Wide Failure in ML Leadership." So that sort of wraps up the whole point in a nutshell, and you can find it easily online. I will continue to delve into the leadership practice, which can't be learned overnight. There's lots of facets to it. In this podcast, I have some other articles, including another article on KD Nuggets. Actually, just search ML or machine learning leadership. You'll find that, and you'll see links in the articles, not only to my own writing but those of my colleagues. So that's pretty much it. Those are the main high-level points I wanted to make today about the lack of deployment and the fact that it's mostly a lack of a leadership practice. So, and to end this, I will wrap it up by just reading the name of that article, the new KD Nuggets article that covers the survey results that I wrote, because I worked very hard writing the name of this article that puts it all as strongly as possible. Models are rarely deployed, an industry-wide failure in ML leadership.